a like distributive thing, you have to have the cosine of an angle. So this is not equal to, put a big old not equal to, cosine of u plus cosine of v. And if I were evaluating the difference of two angles, this is not equal to the cosine of u minus the cosine of v. Because what this means to do is add the two angles. And I could do dot, dot, dot. I don't need to write it out. The same thing applies with sine. So it can be shown through Pythagorean theorem, actually, that the cosine and sine sum formulas are these two things. Now, if you would like to write it in your notes, rewrite it again, you may. Or you can just say, see the sum and difference formulas on the trig properties sheet. And I'm going to just do that. And we're going to just refer to those today. Okay, so really the only thing that we're going to do is we're going to just practice writing sums and differences of angles that we know. So if I said to you then, we're going to use this formula to find an exact value for cosine of 15 degrees. And you might be thinking, well, I don't know, that's not a value on the unit circle. And so here's what our goal is. We want to figure out, are there two angles that we do know on the unit circle that we can add or subtract that would give us 15? And sometimes there's more than one. You said 60 and 45. Could I do 45 and 30 if I wanted to? Yeah. Okay. It isn't. It's just that you're going to get the same result, whatever two you choose. So let's choose 60 and 45. So what we do then is we are going to evaluate it using this formula and using 60 degrees minus 45 degrees. Do you guys agree that 60 degrees minus 45 degrees is 15 degrees? Okay. And then just to kind of help us decode this formula sheet, I'm going to put a little u here and a little v here. And so that's what they represent in this formula up here. So we're going to use the cosine. This is my u, this is my v. This is a subtraction sign. So what is it going to be then here? An addition sign. Okay. So here's what it says. You're going to do the cosine of u times the cosine of v. We're going to write them down. So this is the cosine of, what was my u again? 60 times the cosine of 45. And since this is a minus, I'm going to use a plus. Sine of 60 times sine of 45. Okay, so, and then in our heads, nope, we're going to use our heads, unit circle, and then we'll do one in radians. 60 is pi thirds, right? What is the cosine at 60? 1/2. Very good. What is the cosine at 45? √2/2. So now all I'm doing is I'm using the unit circle and I'm plugging the values in, because this is exact. We're doing it exactly. And what is the sine at 60? √3/2. And what is the sine at 45? √2/2. Okay, so let's simplify our expression then. This is √2/4. I'm just multiplying my fractions together, correct? And √3 times √2 is plus √6 over 4. And I can write it as one thing as root 2 plus root 6 over 4. And this is my exact value. Okay. Now, I think just the way our brain works, it's easier to find things in degrees in this section because we know what 60s and 45s add up to. You might not be quite as familiar with like pi fourths and pi thirds and things like that. But I'll do a couple on the side with you just a second to help us before we do our next one. Just because you might see this today, if I asked you to add pi thirds plus pi fourths together, because aren't those things on the unit circle? You would find a common denominator, so you'd multiply this by 4 over 4, and what would you multiply this by? 3 over 4, and then, do you see I get 4 pi 12 plus 3 pi 12, which is, well, crap. Thank you. You can Jolly Rancher. I think I have some. Yes, that should have been 3 over 3. That was a mistake. Okay, so for today, if you see 7 pi 12ths on your homework, what two angles could we add? Pi thirds and pi fourths. Okay, what if we subtracted them then? What if we subtracted them? I think we can do it without, can't we just look? This would have been 4 pi 12ths minus 3 pi 12ths, which is, you know, thank you. I think that might have been more of a distraction, but it's just pi 12, right? 1 pi 12? Yeah. Okay. All right, so if you're not sure today, try adding a couple together and see what you get. You could also do, you might also see some 8s in there. And for 8s, you might have to use fourths and halves. Okay. So I'm going to do my next one. We just saw these two things, my last one, I guess. And then we're going to show one where we go backwards. If I said to you, find the sine of pi 12 exactly. Well, we don't know the sine of pi 12, but we just showed that there are two angles that we could get to equal pi 12. Pi thirds minus pi fourths, right? Okay, so the first thing I do is I'm going to write it as sine of pi thirds minus pi fourths. See if I have one here. And this is, for my reference in a second, this is my u and this is my v. Okay, we just used cosine below. Would you look right below that? There's a sine formula, and it's a little bit different. Okay. So this says you're going to do the sine of u times the cosine of v. So what am I going to write? Sine of pi thirds times cosine of pi fourths. Nope, it's subtraction. So then the signs here are the same. So then I'm going to do minus cosine of u times sine of v. So what should I write? Times sine of pi fourths, right? Because it's cosine of u, sine of v. I'm looking at the bottom one. Alright guys, let's plug those things in. What's the sine of pi thirds? Root 3 over 2. What's the cosine of pi fourths? Uh-oh. Root 2 over 2. What's the cosine of pi thirds? 1/2. And the sine of pi-4 is √2/2. So once again, you're going to see a lot of √6s and √2s because those are a lot of the exact values on the unit circle. This is √6/4 minus √2/4. I'm going to write it as √6 minus √2/4. Okay. I know we're almost out of time, but this won't take long. You could also rewrite things as one angle. I'm just going to show you one last thing. If you see this, there you go. Now you see it. And if I said just rewrite this as, you can't find it, but just rewrite this as the sine or cosine of an angle. Which of the formulas does sine, cos, cosine? Is it the sine formula or the, okay. So this is my u, this is my v, this is the sine of u plus v. So how could I rewrite it as one angle? The sine of 20 plus 11, or 31. This is just, am I going to evaluate it? No, I don't know what it is exactly, but it's just getting you to see or identify that this is a sine sum and writing it as one angle.